Welcome to the Explainer. Have you ever wondered how to get your Python app to actually remember things? Well, today, we're going to unlock the power of persistent data. And the best part is, we'll be using tools you already have right out of the box. So let's dive in.
So, imagine this. You're building a cool app, right? But then you hit that classic wall. How do you save stuff? Like user scores or settings, so they're still there when you close the program and open it back up. You know you need a database, but man, the options can feel kind of overwhelming. It's like, where do you even begin? All right, we've got a super clear roadmap for this one. First, we're going to uncover the database tools that are already hiding in your Python toolbox. Then, we'll make our first connection, see how Python and SQL actually talk to each other. And then, we're going to hit a really critical security warning. Finally, we'll wrap it all up by mastering the safe way to query your database. Okay, let's kick things off with Section 1, Python's built-in database. And honestly, this is the best part. You don't have to install a single thing, seriously. You're ready to start coding, like right now. So how does this whole thing work? Well, you've got Python, your awesome general-purpose language. And then you've got SQLite, which is this incredibly powerful but super lightweight database. I mean, this thing lives in a single file and runs inside billions of devices, like your smartphone. And the magic that connects them? It's the SQL3 library. It's the bridge between the two, and it comes standard with Python. That's that whole batteries included philosophy we all love, right? In action. All right, moving on to Section 2, making the first connection. This is where it starts to get really fun. We're about to, open the door between our code and our data storage for the very first time. One of the first things you learn in coding is the DRI principle, right? Don't repeat yourself. So instead of writing out the same connection code over and over and over again, the best practice, the smart practice, is to just wrap it all up in a simple, reusable function. And just look at how simple this is. First, you just import SQL3. That gives you all the tools. Then you define a function, which keeps your code nice and clean. But the real key is this SQL3.connect call, where you just give your database file a name. And what's so cool is if that file doesn't exist yet, Python just makes it for you, no extra steps. Finally, you return that connection object, and bam, you've got the keys to your database. Okay, let's keep building on this in Section 3, translating your data types. Now, this might sound a little technical, but it's a really crucial step. Think about it. For your database to actually store your Python data correctly, they both have to be speaking the same language. And this is where the SQLite3 library is just a fantastic translator. It automatically takes care of all the conversions for you. Your Python int, it becomes an integer in SQL. A Python string, that becomes text. It just handles all of it seamlessly. And that means you can just focus on your app's logic instead of worrying about all those low-level, super error-prone details. It just works. Okay, here's a small but really important detail to keep in your back pocket. You know how Python is super flexible with strings? You can use single quotes, double quotes, even triple quotes. Well, standard SQL is a little more particular. For its text data, it pretty much sticks to single quotes. It's a tiny difference, for sure, but knowing these little quirks can save you from some annoying syntax errors later on. All right, listen up, because for our fourth section, I need your full attention. Seriously, if you take away only one single thing from this entire explainer, please let it be this. We are talking about a critical security warning, the one mistake you absolutely must avoid. The threat we're talking about is called SQL injection. And what that means is an attacker manages to sneak malicious commands into your database queries. And if you're not careful, they could do some serious damage. I'm talking viewing private data, changing information, or even wiping out your entire database. It is a massive risk. So here it is, the golden rule. Write this down. You must never, and I mean never, use f-strings or any other kind of string formatting to build SQL queries with data that comes from a user. I know it can seem convenient, but it's literally like leaving your front door unlocked and wide open for an attacker. It is just so dangerously insecure. Okay, so after that pretty serious warning, let's talk about the solution. And the good news is your best defense is not only really simple, it's already built right into the library. Let's get into Section 5, querying the safe way. The answer to all this is something called parameterized queries. And look, this isn't just a good idea. This is the industry standard way to safely get data into your SQL commands. You can think of it like an armored door that just slams shut on any potential SQL injection attack. And the process is just 3 simple steps. Check it out.
First, in your SQL query itself, you just use a question mark as a placeholder wherever a value is going to go. Step 2, you package up your actual data into a tuple, which is really just a simple, unchangeable list in Python. And finally, you pass both that SQL string and your data tuple to the execute method. That's it. The library takes over from there, safely combining them and making absolutely sure your data is only treated as data, never as a command.
So let's do a quick recap of our journey, all right? First, you already have everything you need to use SQLite. It's built right into Python. Second, the library is smart enough to handle all those data type conversions for you. And the big one, the most important one, you always use parameterized queries with that question mark placeholder. And you never, ever use string formatting to build your queries. That's the key.
So there you have it. We've laid the foundation for connecting your Python code to a secure, powerful database. You now have the power to make your applications actually remember things. So the real question is, what's the first thing you're going to build?